In this video, we are going to learn about the product rule using several easy examples. In another video, we're going to learn about the problems of medium difficulty and problems that are hard to find. So you can look at the link in the description. So let's look at what is the product rule. So product rule has several ways to write it. So you may have seen the first version, the product of derivative of the product of f(x) gx equal fx, that's the first function, and multiply by the derivative of the second function plus, so there's a plus sign, and then gx, that's the second function, and multiply by the derivative of the first function. Or you can switch the order. You can write using the prime notation like this. So you can see that f prime x times gx plus g prime x plus fx. So you can see, since this is a plus sign, there's no special order that you can write in any order, but you only take the derivative of one of them, not both. And also there's more common way to write it using the prime notation. So so this is the one we mostly use in this one. So let's see several examples. Find the following derivatives. So let's look at the first one. As the first example, we have we need to find the derivative of x minus 1 times x plus 2. And also be very careful, you need to write a parenthesis bracket here, because if you do not write a bracket, what it means that you only find the derivative of the first one but not the whole product. So be very careful, you don't need to put a bracket around it. Okay, so if you use the product rule, so what happened? So it's very clear what is the first function and the second function. So this is the first function that we can say f. This is second function that we can say g. So if that is the case, then we can write the product rule like this. So this is equals to, we take the derivative of the first function, which is x minus 1, and then multiply by the second function without the derivative. And then we take the derivative of the second function and then multiply by the first function. So this is the product rule. So we take the derivative of only one term at a time and multiply by the other one. Now let's try the rest. So you can see derivative of x minus 1 using the power rule, you can see that it is just 1, because the derivative of x is 1, derivative of negative 1 is 0, so it is 1, times the function which is x plus 2 plus, again the derivative of x plus 2 is 1, and then x minus 1. And this is a little exaggeration. You really don't need to write this 1 here, because when you multiply by 1 it doesn't, but I'm just writing it just for clarity. And then what we do is simplify. So when you simplify, you can see there are x and x, so it's 2x, so you get 2x, and then we have a 2, and you subtract 1, so you get 2x plus 1. So that's the derivative of the expression. So let's look at the next one. So as the next example, we have x squared x minus 3. So again, this is equals to, so if you have the product rule, it is the derivative of the first one, which is x squared, times you multiply by x minus 3 plus the derivative of the second one, which is x minus 3 multiplied by the first one. So again, if you find the derivative using the power rule, and you know that the derivative of x squared is 2x, and then times x minus 3 plus the derivative of x minus 3 is 1 as before, and then times x squared, and then what we do, we're going to simplify this one. So when you simplify, you can see that you're going to get 2x squared minus 6x. I'm writing all these steps for clarity, but you really don't need to write them later. So you can just simplify, so you don't need this step. So you get 3x squared and minus 6x as the answer. So let's look at the next example. As the next example, we have y equal x squared plus 1 times 3x plus x to the 4th power. So we have u and v, so we have two functions u and v. So we can use the uv version here. So y prime is u prime v plus v prime u. So if you use the prime notation, so what happened now is you can say take the derivative of the first one, which is u, so it is x squared plus 1 prime times the second one, no derivatives, plus, now what we do, take the derivative of the second one, so it is 3x plus x to the 4 prime times the first one. So using the power rule, we can find the derivative now. So derivative of the first term is, it is 2x plus 0, so we don't write it, times 3x plus 4 plus x to the 4th. When you put the parenthesis, it means the multiplication, so you really don't need to put the dot here. So plus, and then again derivative of 3x is 3 plus 4x to the cube, and then times x squared plus 1. So we done with the derivative. So at this level we done with the derivative. What we do now is just do the algebra part. So we're gonna distribute the terms and combine like terms. So when you distribute, you get 6x squared plus 2x to the 5th power. And then for the next one, you can either use the FOIL method or just multiply by term. So pick one term and multiply by everything else on the other side. So there are two terms. So multiply these two. So when you do that, you get 3 times x squared, so 3x squared, plus 3 times 1, which is 3. Now do the same thing with the other term. So pick the other term and multiply by everything on the other side. So that means you're going to get 4x to the 5th power from the first one. From the second one, you get 4x to the cube. Now what we do is combine the like terms. So if you combine like terms, we normally go with the largest power first. You can see x to the 5th power is the largest power. So you're going to get 6x to the 5th plus, so the next largest power is, you can see the cubes. So we're going to go with the cubes, so there's only one cube. So it is 4x cube, and the next one is squares. So you can see that there are 9x squared plus 3. So that is the answer. So let's look at the next one. So let's start with a different variable now, because you also need to get used to different variables. That's one of the skills that you need to develop. So in this problem, you can see there are two functions. Again, the first one is u and the next one is v. There's no order, but we just put it like that. And again, we use the power rule, the product rule. So we take the derivative of the first one. So let's directly write it now. So it is 1 plus 2t cube derivative times t minus 5t to the 4th power plus, and then derivative of the second one, so t minus 5t to the 4th power derivative times 1 plus 2t 3. Now we try to take the derivative, so we apply the product rule. Now we're going to take the derivative, so you can see here you're going to get the derivative as 6t squared times no change plus take the derivative, which is 1 minus 20 t to the cube, and then we have 1 plus 2t cube. Now what we do, so we're done with the product rule, so the algebra part. So let's multiply through, so you're going to get 6t squared minus 30 t to the 6th power plus, again if you multiply first term with all the other terms, so you're going to get again 1 plus 2t cube, and then pick the other term, multiply those two. This is the easy way, you just two arrows and multiply them. So it is negative 20 t cube minus 40 t to the 6th power. Now what we do, we combine like terms, so you're going to get a negative 70 t to the 6th, and then negative 12 t to the cube plus 1. So those are the terms that's the final answer. So let's look at the last one, little complicated one. So as the next one, we have d by dx square root x times x minus x cube. So this is again very similar. So we're gonna pick the two functions u and v. So the product rule is u prime v plus v prime u. So I'm gonna write it here because it's a little long. So it is the derivative of the first one. We write square root as x to the 1/2 because it's very useful when you write it like that. And then multiply by the second one plus take the derivative of the second one, which is x minus x cube, multiply by the first one. So using the power rule, you can see the derivative is 1/2 x to the, we subtract 1, negative 1/2, and then x minus x cube plus, if you take the derivative is 1 minus 3x squared and times x to the 1/2. So we're done with the derivative. So the next step is we're gonna do the algebra part. So when you do the algebra, when you multiply through, you're gonna get 1/2 x to the 1/2 minus 1/2 x to the, so you have negative 1/2 and 3, so it is you can write as 2.5 plus, and when you multiply you get x 1/2 minus 3, and you can see you add 1, so you get x to the 2.5 again. Actually here 2.5. So now what we need to do is we can write this in like a kind of interesting, nice way. So we can first combine the square root terms. So we have those two. So you're gonna get 3 halves square root x, 1/2 is square root power, and then also we can combine the other two. When you combine other two, and you can see that you're gonna get negative 3 halves x to the 2.5, and 2.5 you can write as a fraction. So because 2.5 is, you can write this one as 2 and 1/2, and then we can write this one as 2, and then what we do is we're going to multiply these two numbers and add this one, right? So multiply and add, so you're going to get fifth. So that means your final answer you can write as 3/2 x to the square root x minus, so do the same thing here. So this is 6 plus 1, so that means 7/2 x to the 5/2 as the final answer. If you also need the radicals, you can write this one using radicals too. So it is 3/2 square root x minus 7/2, and you can see you can take the x to the 5th power and take the root. So you can write it like that as a final answer. So now what you can do is you can try these problem as practice problems. Now use the methods that you learned earlier to find the derivatives of the following functions. So there are 5 different examples, and see whether you can find the derivatives, and you can match the solutions with the answers given in the description. And in another 2 videos we do problems of medium difficulty and problems that are a little harder than these. Thank you for watching.